Hi everyone. Today we are going to discuss about the different types of the boilers. Okay, in the thermal power plant. So in the previous session we have seen about the working working out of the thermal power plant. Okay. So here today we are going to discuss about the thermal power plant main components, that is the boiler. Okay. So here in this case the main components of the thermal power plant is the first one is boiler. The boiler name is, it can be defined as a closed vessel. It is a closed vessel in which the steam is produced from water by the combustion of the fuel. Okay, so that means it is the products, the combustion of the products passes through the tubes. Okay, so which are surrounded by the water. So depending upon the whether the tube is vertical type or horizontal type, the five tube boilers are divided into two types. So those are the vertical tube boilers and horizontal tube boilers. So five tube boilers, it is a simple, compact and rugged in construction. Its initial cost is very low, and water being more and circulation being poor, they cannot meet quickly to changes in the steam demand because they cannot withstand for the high temperatures for five tube boilers. So, in the water and steam, both are in the same shell, right? In the five tube boiler, if you see in the diagram, so this is our five tube boiler diagram. So, if you see this is the whatever the fire, that means the hot flue gases, okay? So that flows in the tubes, okay? Now, so there is no contact between the water and fire, okay? So this hot flue gases flows in the tubes and the boil is filled, that means the water is filled in this container. So the according to the thermodynamics principle, so the temperature of the this hot flue gases is passes to the water, okay? So here in this case, so the water and steam, that means the water. This is our water and this is our steam. The sky blue color shade is steam. Okay. So this steam is both water and steam are present in the same shell. Okay. Na? So this is our five tube boiler. So that is not whatever we want the pressure of that high steam. So that is not possible in this five tube boilers. Okay, so because of the both the steam and water are present in the same container, okay, or same shell, so the pressure of that higher pressure it's not meet, okay. So that is the maximum pressure which can be had. So what is the maximum pressure in that shell? So that is the 17.5 kg per centimeter square with a capacity of 15,000 kg per of the steam per hour. So for the same output, the outer shell of the fire tube boiler is much larger than that of a water tube boiler. So if we want that same capacity of that, okay, so that is the pressure range is 17.5 kg per centimeter square. So that we need the capacity of the boiler, okay. So outer shell of that boiler, fire tube boiler is much larger than that of the water tube boiler, okay. So in the event of sudden and major tube failures, the main disadvantage of this one, the steam explosions may be caused in the furnace, okay. So that is the, if any sudden increases in the fire or any failure in the tubes, there may be a chances of explosion, okay. So that is the major disadvantage for the fire tube boilers, okay. Steam explosions may be caused in the furnace due to rush of the high pressure water into the hot combustion chamber, which may generate large quantities of steam in the furnace. Fire tube boilers use therefore limited to low cost, small size and for the low pressure plants only. For the smaller rating of the power plants, we are using furnace, that means fire tube boilers only. Okay, so now we are going to go for the water tube boilers, okay. So water tube boilers are, so see the diagram, water tube boilers, okay. So here there is a water tube boiler is the main water flows inside the tubes, okay na. So the hot gases flows outside of the tube. If you see the diagram, the water is flows inside the tube and the gases flows outside of the tube. There is a separation, okay. So that is the main. The water tube boilers are classified as again in this type based upon the construction type. So there are three types are there: vertical tube type, horizontal tube type, and the inclined tube type. So if you see this diagram, this is the inclination is there, right? So this is the inclined tube boilers, okay. So the circulation of the water in the boiler may be natural or forced. For central steam power plants, large capacity of the water tube boilers we are using, okay. So the tubes are always extended to the drum. They can be built in smaller size and therefore withstand for the high pressure only. The boiler drum contains both steam and water, and the former being trapped from the top of the drum with where the highest concentration of the drive stream exists. So here there is a top of the, okay, top of the drum. The higher capacity of the high pressure steam is steam is outlet is present, okay. So this is the water tube boiler. So this is our water tube boiler, okay. So here in this case, so the major components, another one is superheaters and reheaters. So here the major component, first one is superheater. Superheater means what happened here in this case. The main function of the superheater is to increase the temperature of the steam above the saturation point. So the main concept of the superheater is what? So it will increase. If you see the diagram, so this is our superheater. Okay, so this is our superheater. This is our boiler. I mean drum. Okay, so here in this the furnace is drum going on, and from the furnace the hot flue gases are flows into the superheater. So the what is the main point? So it increases the temperature of the steam above the saturation point. So whatever the temperature range is there, the saturation point, above saturation point we have to increase. So that point is increased in this case. So that is the superheater, okay. So this is our main circuit of the main diagram of the superheater. So if you see the fine function of the superheater is to remove the last trash of the moisture from the saturated steam. Okay, so that means the above saturating point level increases the heat energy. So that is the any moisture content in the steam, so that will also removed in the superheater, okay. So it will increases the above temperature levels. The steam leaving from the boiler tubes is also increases the temperature above the saturation temperatures. So for this purpose the heat of the combustion gases from the furnace is utilized, okay. Superheated steam is that steam which contains more heat than the saturated steam at the same pressure. So here the additional heat provide more energy to the turbine, hence power output is more. So the superheated steam causes lesser erosion of the turbine blades and can be transmitted for the longer distance with a little heat loss. So, however, it is a convection type or radiation type or combination of these, both radiation and convection type. So, how the way of heat energy is transferred to the steam. Okay, so the process is radiant type or combination. That means convection type. Okay, so these are the main components of the thermal power plant. And one more thing is a reheater. Reheater is also there. So in addition the superheater modern boiler, it is having a reheater. Also the function of the reheater is superheats the partly expanded steam from the turbine, okay. So this ensures that steam remain dry through the last stage of the turbine. And it is a reheater, maybe convection type or radiation type or both the combination of the types, okay. Thank you guys.